Hello everyone, I'm Edith and welcome to our Percona YouTube channel. Today we have a special guest, Vinodh Krishnaswamy. Hello Vinodh.
Hi Edith.
Vinodh, thank you so much for your time. Could you tell us a little bit more about yourself?
Yeah, thank you Edith for this opportunity, and I'm very happy, very happy to be here and to share my knowledge with you guys. And myself is Vinodh Krishnaswamy, and my friends call me as Guruji. So my tech world friends knows me as Guruji, and I'm a proud Perconian for last 7 years, and I'm here working as a support engineer, and I'm working in both in MySQL and as well as in MongoDB technologies. And I'm just another soul who wants to share my knowledge with you guys.
Yeah, thank you. So that's the reason you're here collaborating with us in this video because we want to learn a little bit more about MongoDB and operators. Vinodh, tell us more about what we are going to cover in this demo today.
Okay, so here I would like to give a small intro about what is this Kubernetes and Helm charts and everything. And after that, we are going to install Percona Server for MongoDB operator. And I will give you some heads about what is this operator thing and why do we need to install Percona Server for MongoDB operator to use MongoDB, and what are the components that we can use inside the operator and how we can change that. So we are going to see the installation part and the configuration part, the basic configurations. Maybe we can cover the advanced things and other parts of MongoDB in the further videos of this series.
Yes, that will be nice. Okay, so let's start the Vinod.
Okay. Thank you, Edith. Let me start. So first, we go into this particular topic. I would like to give a small intro about what is Kubernetes and what is Helm, because a lot of time when I work with the customers, they get confused about like Kubernetes and Helm charts and why they different one and what is Minikube, and somebody asks like what is kind and everything. So let me give I think it will be easier for you to understand if I give a small intro. So Kubernetes is basically a kind of a container orchestration. Orchestration is kind of a technology where you can deploy your servers, and then when in some failure or when some condition is not meet, it will try to promote the other server. It's a kind of a switchover or a failover kind of situation. So this Kubernetes is going to tackle all those things by its own. So we call it as a container orchestration, and the deployment is very easy. You don't need to actually deploy one server and install one by one, and you need to check whether all those softwares are installed. You don't need to do everything. So once you template your things, everything will be done automatically, and it's a kind of a self-healing technology. That means like if some parts go down, then the Kubernetes will automatically try to recover that, and it will bring that particular application pod or a database pod by its own. So that is one of the main advantage here. And the scaling part is very easy. For example, if you are running MongoDB by your own, if you want to scale it to, for example, if you wanted to add two more nodes to the replica set, you have to add one server, you have to install database there, and then you have to do some commands in the MongoDB prompt, and you have to tell MongoDB to do the initial sync. Everything you have to do manually.
Yeah.
But with Kubernetes, it's a simple change in the CR .yaml, and it will do the change automatically. So it reduces the man intervention, and so that it is kind of a automatic automation is happening, and it makes everything easy in your life. So it's a kind of technology where you can roll out changes or roll back changes very easily. And if you use Kubernetes very well, it's a great technology for you. About Helm charts. Helm chart is basically a Kubernetes, but it is a package manager. I mean, like it's a kind of a package where you will have charts. Charts in the sense like you will have a previously defined templates available. So when you're installing in Helm, you will be already have some templates, and you will be installing them, so that you don't need to do lot of other stuff as well when like you do in Kubernetes. For example, in when you're installing Kubernetes, you have to install Kubernetes, and then you have to make sure you are applying the changes and everything and all. So, but with Helm, it is more easier than that. So it is making your life more easier. Operator is both like in Helm as well, and in Kubernetes as well.
Mm-hmm.
So what I'm telling is, in with Helm, you will be having more predefined templates. So you uh, you'll be doing all the changes like versioning, or like dependency management. So everything you can automate with the Helm. Okay, it's also kind of a operator.
Mm-hmm.
And for example, in Percona Server for MongoDB operator, we have two charts for Helm. One is the operator part, and one another one is the DB part. Okay, the operator in the sense like it will take care of our custom resource definitions automatically. And also it has to, for example, when I'm telling about self-healing, how Kubernetes do that automatically. So you need to write a code to tell the Kubernetes, the operator, that when one of the database node goes down, you see why it is going down and bring it up. When I'm changing the size from 3 members to 5 members, I was telling you, right? You have to add servers, install
Yeah.
MongoDB, and you have to attach to this particular replica set, and you have to do the initial sync, that is data sync between the members. So these things will be handled by the operator. Okay, so
Yeah.
Kubernetes is kind of a basic skeleton structure. Operator is kind of a mechanic who fits all other things, components inside that
Mhm.
basic structure to make it as a good product. Okay, and Helm is something in outside, which is having the charts, predefined chart, the database chart, and as well as the operator chart. When I want to for example, if I want to upgrade from one version to another version, I just need to upgrade the charts. So automatically inside that one, it will upgrade our operator as well. And also the changes to our database will also be happening automatically. You know, like the you are reducing dependency. So the end product, what we are going to get with this method and Helm method are same, but the approaches are different. Let me share my screen
Yeah.
so that I can show you
Yes,
the
that will be
presentation.
nice.
Okay,
Mm-hmm.
before installing Kubernetes, you need to have some prerequisite attended. That means like you need to know what application that you are going to run, and what are your system requirements, and maybe the application requirements. For example, here when we are talking about MongoDB operator, we need to know what your application is going to. Does it need replica set or sharded cluster? So sharded cluster is basically like you're going to shard your data uh, into multiple shards. Okay, but with replica set, you're going to keep everything in same server, but it will have automatic failover when one goes down. So you will not lose your data. So there is high availability available with this replica set. So with sharded cluster also, we'll be having replica set, but we'll also have shards. So you can shard your collections so that you can split up your data and keep it in multiple shards. Okay, so when you're having a data size like more than like 1 terabyte or 2 terabytes kind of thing, you can go with shards. Otherwise, you are good with replica set. And the other thing is like I said, what type of storage you are going to use and what type of load you are going to use. So that based on that, you need to avail CPU number. For example, for the simple application, 8 core CPU or 4 core CPU, core CPU is are enough. But if you are going to have a very big load and you are going to expect a lot of connections and requests to the database, then it is best to have at least a 16 core or 32 core CPUs. And the one another main thing is network. Okay, in within Kubernetes, you need to decide whether you are going to access everything within that Kubernetes network or you are going to expose your application to the outer world. So based on that, you need to design your uh, Kubernetes thing, like what I say, like your application side, and you need to work on how to expose the database pods. For example, sometimes you don't need access. Only your application is going to access your database, or sometimes you may need to allow some users to access your database from outside. Okay, so based on the use cases, you can work on this network thing. And other main thing is where are you going to deploy your operator, whether it is going to be cloud or on-prem. Okay, based on that, you can work on that. For example, if you're going to use cloud, whether it is going to be the GCP or AWS or Google Cloud or Azure, so you need to work on that as well. And the other thing is security, whether you are going to have your own certificates, CS certificates, and what is your model to create users, and what are the uh, roles and access privilege that you're going to give to the database. So those things you need to plan ahead. Because when you're creating the operator, you're going to define all these things itself. So it is very important for you to decide all these. And so this is one of the tip I'm going to give you here. For
Mhm.
example, sometimes you may want to test our operator in your local machine, whether in your computer, PC, or laptop. So in that case, you don't need to worry about having the cloud environment or on-prem environment. You can install one of these tools which comes with a Kubernetes installation. So it will help you to create your database operator very fast and to help you to test in your local machine itself. So today we are going to use Minikube, and I will show you how to start our operator with using Minikube.
Okay.
And after that, you need to know what is MongoDB and its advantages and what are the components you are going to use. And when I was talking about replica set, Shada cluster, I meant this only. And below operator, you have a lot of components like custom resource and the upgrades, scaling, backup, restore, and self-healing kind of things. So when you're talking about operators, this operators is going to take care of all these components. Scaling part, if you want to add more database nodes, it can do. If I want to take backup and if you want to do restore, we can do that with the operator. And self-healing upgrades, because in Percona we have Percona extra DB cluster for MongoDB, MySQL operator, and Percona server for MySQL operator as well. So we have operator for Postgres as well. So all these operators give you the facility for upgrade, scaling, backup, restore, monitoring. All these facilities are there, and you don't need to worry about configuring all these things separately. So you can do all these things within your operator automatically. Yeah, it is open source, and you are welcome to use them and test them and use in your production. So whatever the thing we have, every features available, changes available in our release notes. So always you can, for example, here if you are going to, for example, Percona operator, MongoDB, you will get our documentation in the first link itself. So you can just go and check our operator, what are the features available. And we have given our architecture, how it is working, and comparing with other solutions. For example, here you can check with other operators, with a community operator, enterprise, and other Helm charts. So we have given all the documentation information that you need for you to choose easily. So here we are going to maintain our users, and for example, we have predefined users before you start our start our database, like backup users, monitoring users, or user management users, admin users. Okay, so these users are available as secrets. So if you want to change passwords, or if you want to change the username, you can change our secret so that it will be deployed when you're installing our operator. And with CR, you can mention the size of the replica set, or whether you want to enable the sharded cluster or not, or how, or what is the memory that you want to allocate for your replica set, how many Mongo is pods you want to create. So everything is available here. For example, if you want to know what are the choices or the parameters available for this one, and you can check our URL, that you can check all the options available. So if you want to do some changes, you can go to our cr.yaml and changes all these things. So that I'm going to show you in few minutes. So I will tell you how you can change these things and why it is important, and everything I will show you in few minutes.
Okay, sounds good. Okay, so now it's time to do a demo time, Vinod. So feel free to share your terminal and yeah, what we need for this demo. You can give us an introduction of what we want to achieve.
So let's dive into the MongoDB part, operator part. Like our GitHub where our coding is there. This is the link. You can go and check our coding. The latest version available right now here is version 1.17.0. So you can go to our GitHub and download that one. And uh, with our operator, you can deploy replica set, or else if you want to enable sharded cluster, you can do that as well. And PPM is a tool available in Percona, which is used to take backup for our MongoDB. So it is kind of a Percona backup for MongoDB solutions. By using this, we are going to take backup and also to restore within our operator. And PMM is a big monitoring service, which is going to monitor your database, and it will tell you what is happening with your database. And I highly recommend you to enable backup and monitoring if you are going to use our operator. Both are open source and you can use them
Okay.
without any hesitation, and it is production ready, so you can use it with your production. And the beauty about PPM is like I can take it as a separate we are going to talk about this PPM in a separate video, but it is a great solution. And like a lot of our customers are using PPM, and so I also suggest you to use that. So let me dive into how to download our operator and how to start our local Minikube setup. And for me, let me first start with Minikube. So I'm going to start with the local setup. I'm for this, as I said to you, I'm going to use Minikube here. And apart from Minikube, I also suggest you this K3s, which is very light Kubernetes setup you can avail within your local one. But right now, I'm going to use Minikube here, and I think I have already have it's running. But for convenience, I'm going to show you how to start this. Before this, I'm going to delete the existing one. Okay, and I'm going to start a new one. So when you're starting new one, so you can allocate the amount of memory and CPU and disk for this particular Minikube setup. So when you start this setup, so it will allocate 5 GB of RAM size and 4 CPU cores and 30 GB of your local storage. So it is going to create a test setup there, local setup there. So you can see that it is creating Docker container with this, and it is going to take just within a minute. Okay, so you will have your setup ready. So here you can see it is preparing Kubernetes as well. As of now, it is installing 1.2 28.3 on Docker, and it is also create a control plane and everything. So once it is created, you can check what is the status of this one. Okay, so it is running. Kubernetes running, API servers running, config is served. Okay, and uh, if you see here, this is the one Minikube which is running this setup. Okay, I have other PMM and Neo running on my local. You can ignore them. So this is the one we have started right now. Here you can check a quick check whether your kubectl is set up properly or not. So this is a simple command. And if you want to check in all namespace, you just have to add hyphen capital A. It will tell you all the, you can see that etcd, API server and everything is set in your local setup. So everything is with a Minikube. And when I usually work, like I try to create a alias for this, like a kubectl equal to k. So instead of typing kubectl, you just have to type k.
Yeah.
Okay, so like this. So it's a shortcut. Okay, but again, I'm not going to use it, but you can use that one. So here we are going to create one namespace for us, and that is where we are going to install our MongoDB operator. That is Percona MongoDB operator. And after that, you have to download our MongoDB operator from the GitHub, and that you can do from here. As I told you, you can just get it immediately. GitHub Percona operator, and this is extra. Yeah, you can go to our Percona thing and GitHub for Percona here, and you can search for MongoDB, and you will get all other projects with MongoDB. And we need to go inside this Percona server MongoDB operator. And we are going to clone this project into our local and going to start operator from there. So if you want to check which version you are going to use, you can see under this tags. And for this particular test, we are going to use 17, the latest one, 1.17. And before that, you can copy this link to clone. And to clone easily, you can do this. So it will download all the files into your local, so you can work from local itself. You don't need to, for example, if we have a server where you don't have internet connection, you can download like this, and you can move this or these files
Mm.
to your server. For example, sorry. So
Mm-hmm.
you can see that set of files download here. And here for this one, we are interested inside this deploy directory where you have YAML files available for you to configure and deploy.
Yeah.
So here I'm going to use like this, but there are other ways as well. For example, uh, if you go to installation part, for example, if you go to this installation, we have documentation for that. So you can just directly call our URL as well. If you have internet, you don't need to actually download the GitHub project like I shown you. You don't need to clone that. You can just call this directly. But I prefer this way of doing so that I can see what inside my script and everything, because I try to edit things so it will be easier for me to do things. So as per your convenience, you can do this. For example, if you don't want to change anything and you are going to just apply things and start things, you can use like the command given in our documentation. But here we are going to do some configuration. So I'm downloading the things into my local. So like I said to you, this is CRD, which is custom resource available. If you open that, you can see a lot of other tags and the classes, and you can see the restore, how is restore is there, and how is backup. So backup things and everything is defined inside this custom resource. Okay, and we are not going to touch this one, and we are going to change secrets. Okay, for example, if we are opening this secret file, you can see this backup. I was telling you right earlier, you have backup user, database admin user, cluster admin user, user admin users available, predefined ones. So if you want to change some passwords, you can do this like this. You can change in this file. But usually what happens, it is not recommended to keep your passwords or your user like this. Okay. How you can keep, for example, here, the backup user password. Okay. So the user password is like this. So instead of using that one, you can use the base 64 of that one, like this wrap equal to 0. Like I said, secrets will have this basic predefined users, username and the user passwords. And here in this particular file, you are seeing everything as a plain username and plain passwords. Like if somebody is going to refer this file, they can actually understand what is this and what is this username, what is this password.
Yeah.
So in order to prevent that, you can encode our username and password using base 64. To encode that one, you have to use command like this.
Mm-hmm.
Okay, and it is not B, actually it is a N. Okay, and you can use B as well. So let me try to show you.
Mm-hmm.
Okay, so this is what happens when you see. Okay, so instead of backup, now right now I'm going to use this particular encoded one, and our Percona operator is uh, uh, written in such a way that it can understand this base 64 encoded one. So I'm going to use this one instead of the plain password, which is visible for everyone.
Yeah.
Okay, so like this I can use it. Okay,
Yeah.
and let me let me simply just try to
Mm-hmm.
do this quickly.
Mhm.
Okay, and 1, 2, 3, 4, 5. Okay, so we are going to use this. this.
The password of the
So
database.
like that, you can change for everything. So I'm going to stop here.
Yeah.
Okay, and so it looks like this. Okay, so
Mhm.
um, it is advised to you to use like this. And after this, you have to change our cr.yaml. Okay, and before changing that, I'm going to take a copy of this one so that I don't change the original one. So you can see lot of parameters and values here. For example, my cluster name, what should be my cluster name, and whether what should be my upgrade options. It is a smart upgrade or how is that, and what is my secrets. Okay.
Yes.
And for example, I told you, right, I'm going to run. This is the basic thing. So if you are going to run, it will actually start with the three members for your replica set. And for example, if I want to check for sharding, it is enable true. By default, you will also be starting your sharded cluster by default. If I want to uh, if I don't want to enable it, you can change that one. So these parameters, to understand these parameters and how to change this one, that you can check our documentation as it's told you earlier. Options for MongoDB. Okay. So in order to get the options, you can go to CR options for MongoDB and go to reference and custom resource options, and you can see there the options. For example, if you want to see the replica set size, you can see the number of replica set members available in this one. So if I want to change that one, I can go there and change. And for example, if I want to go to sharding section, and you can see that shard enable is true or false. I can enable or disable sharding based on this.
Mm.
So by this way, you can refer our documentation and do the changes. For this particular setup, I'm going to disable the shard cluster. So in Kubernetes, we have everything as nodes, ports, containers. Okay. So for example, if this is your Kubernetes, okay, and inside your Kubernetes, we have nodes, okay, and we call this as, for example, we have 4 nodes, and we call this as control plane, okay, and where you we this particular node, okay, so these are all nodes. And this is called control plane node, and this is called worker nodes. Okay, worker nodes. Okay, and can and these are all worker nodes.
Yeah.
Okay, and what happens? This control plane controls everything. Controls everything inside the worker nodes. For example, when you are installing our database operator, what happens? Our operator is going to put. For example, let me. I'm just going to use this particular node. Okay, it is going to install a pod here. Okay, inside pod you will be having multiple containers. For
Mhm.
example, we have, let me show you. Okay, so I told you, right, in our database pod, in our operator, we have database and PBM and PMM, monitoring, backup, and database. So when you're running this particular pod, okay, so this is pod and this is container. So for example, DB container. Okay, and this is PBM agent container. That is backup container. And this is
Sorry.
PMM agent. So you can like that. Okay. So inside pod, you will be having these containers, and these containers will be running whatever you need. Like this is what our operator is actually running. For this particular setup, we have our operator where we have lot of our arguments which control these things, like how many pods we need, like how many members we need, and there is a concept called affinity as well. For example, affinity makes sure that your particular pod sits on particular node. For example, if I have three nodes and if I have three members in our replica set, our operator makes sure that every particular member sits on each node. So member one in node one, worker node one, and member two in worker node two, and member three in our worker node three. So this is the basic concept. So basically, if you see here, I was telling you like control plane and the worker nodes. So basically inside the control plane, you will be having all the administration parts kind of components like Cube API server, etcd. This is the a kind of a database where you stores everything, and scheduler. This scheduler makes sure that it is scheduling all your pods. When it goes down, it brings up and everything. Control manager, okay, and like affinity. And this worker node is having kubelet, proxy, container runtime, and everything. So this is the basic thing that you need to understand, so that when you're running in your local machine,
Yeah.
if you see here nodes, you can see only one node, that is control plane. So here minikube is starting only one node that acts as both control plane as well as the worker node.
Okay.
Okay, so this is something extra on to top of our operator. This is not part of our operator. To run our operator for basic replica set, you need to have one control plane and three worker nodes. So here we are going to change some affinity values so that it will create all the, so instead of creating everything inside different nodes, every pod into different nodes, we are going to have only one control plane which going to act as um, which going to act as worker node as well as the control plane. So everything is going to happen here itself. And this is only for our local setup. This is for not for your production or whatever. your testing environment or something. Only for your local setup, you can have this kind of thing. So we are going to have pod 1 here and pod 2 here and pod 3 here. So we
Mhm.
are going to put everything inside this one itself.
Mhm.
Okay.
Okay.
So for that, we need to change the thing called affinity. So for example, when I show you that etcd API server control, these are all part of the control plane. Okay. And we haven't started anything on our own. So this is just part of the control plane. And for now, we have created the namespace called PSMMDB, and we are going to install everything there.
Mhm.
And before that, let me edit our cr.yaml. And inside that, you can see affinity. So affinity, you can search and you can see the affinity topology as host name. So based on the nodes, everything is going to be put it into different nodes. Okay. If you want to control, you can, if you want to add more affinity to this, you can do this. You can change these things. Okay. And for example, if you want to, if you are using your cloud, okay, and you want to put this particular node on particular region, so then you can control these things. Okay. And here I'm going to put everything into same node. So I'm going to put none value into our topology.
Okay.
Actually, these are all coming under different things like a sharded cluster, replica set. So you need to change everywhere. Okay. So if you see here, this affinity comes under replica sets. So this is the main replica set. And for example, if you want to have arbiter, in replica set, you can have arbiter as well, which does not contain any data node, but it only participate in the election for promoting the primary. So by default, it is false. Okay. And you can start one affinity. It is allowed in our operator. And if you are going to enable true there, then this matters. Since it is enable false, if you don't change here, that doesn't matter. Okay. And here we have disable our sharding. So, okay, so we haven't changed it here yet. So we are going to disable this.
False.
So, so affinity comes under the Chada cluster, doesn't matter if you are disabling that. Okay. And I'm not going to change one another option, but I'm going to show you.
Mhm.
Okay. So now I'm going to show how to install this, apply CRD, RBAC, and then everything, right? So instead of doing that, we can apply them as a bundle. So to do that, we have to use the bundle.yaml file. Okay.
Okay.
And by using this bundle.yaml file, we can install CRD and RBAC and everything. Okay, and I'm also going to use our namespace that we have created.
Yeah.
So if you see get pods, you will not see anything because everything is created under PSMDB.
Maybe. Mhm.
So you can see our operator is started and running.
Yeah.
Status is running. Okay, if you want to see other components created under PSMDB, you can see the deployment is created, replica set has been created and everything. Now we are going to create our stateful cell set things like our database pods. And to do that, I think we have already edited, and we have replica set
Mm-hmm.
size and everything is mentioned. And we are not going to start with Sharded cluster first. So that is enable false. Let me apply this again now,
Okay.
but it will fail. I will tell you why. But it may not. But we can see only operator is running. We
Mm.
didn't see any database pods running. That is because if you see, that is because there is a thing called unsafe. So inside our cr.yaml, you can see this particular flags, right? Unsafe flags. Here, I have changed the affinity, and also I have changed some values, right? So when you're changing values, you need to instruct our operator that it is fine. I am actually changing the defaults. Operator that I'm purposefully changing the things. So I'm going to change this and making it as true.
Yep.
Okay, so this I changed. So this I have to make true. So now I can apply again. You can see database pod started running.
Mm-hmm.
Okay. So to track them, you can use -w, which will help you instead of typing again get pods, you can just use -w. It is kind of a tail -f of your file. It will tell you the changes happening. So right now, this pod is fine, this pod is fine, and the third pod is getting ready. It is ready.
Nice.
Control C, and with W, if you see, everything is ready. Now we are ready to connect to our
Database.
deployment. So
Mm-hmm.
yeah. So before going into that, I want to show you something. Describe. I want to show you this particular pod
Mm-hmm.
inside PSMDB. So if you see here, you can see that what happened. You can see the uh, containers. So under this container, you can see MongoDB container and backup agent container. Okay. If you would have started enable PMM, you could have seen that container as well. PMM agent container as well. So this is what I was explaining to you here. Okay. Under pod, every containers was running. Okay.
Okay.
And okay, so you can check what is happening and what was the options that it has used. I haven't changed any CPU or memory available or port or replica set name. I haven't changed anything. You
Mm.
can see that memory available for this is 500 MB. And you can also verify uh, the cluster name and everything. And what is the database version it has, what is the image that it has downloaded. For example, you can see pulling image here, operator here, and you can see if it has pulled 7.0 image. Okay, so like this you can see inside the describe, and you can make sure that everything happened properly. So pods you will not get because it is under PSMDB namespace. You can see everything is running. To connect to our pod, there are two ways. One way is you can directly log in inside our pod. At least one command. Okay, sorry. Bash.
Mhm.
Okay, so I'm inside this pod. If you see MongoDB, you can see MongoDB is running
Mhm.
and we can connect to that. But you will not see anything because you are not authorized yet. And do you remember that the secrets
Yeah,
we were talking?
yeah. Mhm.
So we have to use this user for connecting that one.
Mhm.
So I'm logging in again and connecting here and use admin
Mhm.
and I am authenticating, that is cluster admin and this particular username, and
Mhm.
you can see authentication failed.
Why we don't
Why?
use MongoDB user admin user, MongoDB user admin user, user admin password?
If you want to create any user, you can use this.
Okay.
Okay, this particular user
Yeah. Mhm.
has privileges. Okay, okay. I think I need to add this as well. I'll just do this exercise and I will tell you what it is.
Mhm.
Okay, I got it now. Why it got failed? Okay.
We
Do
need
you see
to,
that password is different? It is not
yeah.
the same password.
We converted. Yeah. Okay.
Okay, let me go. Okay, let me start this password point. Okay, so once you get everything inside your database, it's time to connect to your database. Before connecting to that, please make sure that what are the users that we have created with this. Okay, and if you would remember, we have edited our secrets file, but if you see this video, we haven't applied that explicitly. That means that if you see here, when we applied that bundle, so it applied the secrets automatically, inbuilt secrets. Okay, and it chooses the password automatically. And if you want to have a particular username, particular password, then you need to apply this YAML file explicitly. Okay, since we haven't applied this explicitly, you can refer what is created under our deployment by using this particular secret name, internal my cluster name users. Okay, and how to see that? You can use this command, get secrets, that secret name and the particular namespace. And you have to see in the YAML file format. So you can see like this. Okay, you can see that encoded format. Okay, you cannot actually, the operator will not show you in the plain format. So we have to decode that. To decode that, for example, I want to connect here as a cluster admin. To decode that, you can use this command, base64-d. So this is the password of this one. And what is the,
Admin, we need the user also, right?
yeah, user.
Mhm.
So user is cluster admin and password is this one.
Okay.
Let me copy this So now we will connect to the database, which is under PSMDB namespace. And here we have to connect to this pod.
Mhm.
So I have connected to this. If you check, Mongo is running.
Yeah.
And if you check uh, PBM, it is not running because we are connected with MongoDB container right now. By default, it connects to MongoDB container. If you want to check our backup agent, PBM agent, you need to log in to that agent. For example, here I can log in into that agent as -c backup agent. Okay, so here you can see PBM. I think it is PS is not running here, but you can see PBM agent is installed and you can see the binaries. But if you run MongoDB and all, it will not work because it is not there.
Okay.
So let us log in into MongoDB pod, and you can see that if you see PBM, it is not installed. You can see the PBM command is not found, but MongoSH, you can log in there. Okay, so they are both different containers running in the same pod.
Yes. Uh-huh.
And let me connect as a user. We have cluster admin user. Password we have taken here. Where is it? Where is it? Okay, this is the password. Okay, one. So now I can see show DBs and everything because I have this cluster admin privileges. So if
Mhm.
you want to create user, you need to connect as a user admin, and then you have to create those users that you want to create, and you can grant roles to that. Okay, so this is how you have to install and connect to your user. But as a database administrator, you can connect like this. Okay, but if you want to connect from application, you can use this particular URI, and that is given inside our this thing. For example, as this, you can run a image for temporarily, and you can connect to that. For example, if you want to connect as a URI from application, you need to connect through this one. Okay, so you have to use this particular host name inside your particular application. This is the host name you have to use, and username, password, and everything. So when you are writing code, you have to use this SRV URI to connect your database. When you are a database administrator or when you are running locally, you can directly log in into this particular pod and connect to that. But if you want to connect from outside, but using the Mongo SH connector, you can use this particular command. So like I said, you can connect to the database by logging into the pod and connecting to the database directly. But that is only for the database administrators, but it is not for the application user. For application users, you can use the URI, and in our documentation, you can refer here. Since we haven't enabled our sharded cluster thing, we can use this particular SRV URI one. Okay, so when you're using this URI, you can directly connect to our MongoDB. So how to connect to this URI? If you are not using application, but still you want to connect to our database, you can use this particular, you can run a intermediate pod which has this 7.0, whatever the version that we are using, that image will be having inside that pod. And using that pod, we'll be connecting to our database. Let me copy that, paste and here. And since it is let me give some name like a plain lane, and inside PSMDB namespace, and I'm going to create this. So you can see that it has created. And if you see that, you are able to connect. So Mongo SH is there. You have to pass the URI so that it will connect to our system. Let me connect, copy this. And if you see here, namespace, namespace is PSMDB.
Yeah. Mhm.
And the cluster name for us is different one, my cluster one. And I think we can cross verify that. So this is the command to check what is your cluster name. So this is our cluster name. Get PSMDB. Yes. If you want to check the backup, you can check like this. We don't have any backup, so it is. So this is our cluster name. So let me replace that. And our cluster admin is different, and
Do we
password.
need to clean or copy the password first? I think we have a typo, but go in the name of the cluster, my cluster name. It should be use my cluster name or RS0. Could you see?
My cluster name.
Okay.
So
Yeah.
we haven't edited our CR file, right? If, for example, if you see our YAML file, okay.
Mm.
So you can see our name as mentioned as my cluster name.
Okay.
So that is, if you change there, you will see different name here.
Okay.
So we have to use that cluster name here and cluster admin and password, and we are good to go now. So we are connected. Show DBs. Okay. So
Okay.
this is how you connect intermediately. So once you come out of this, this pod will be deleted automatically. You can see that it is deleted. So if you connect it again, it will be created again. And you can again use this particular command, Mongo SH, and you can change the username passwords there. And in further video series, we can see how to create users and how to change these secrets, and then how to enable backup and how to restore. So like you said, like we have seen what is Kubernetes and what is Helm, and then what is the control plane and what is the worker node, and how to set up our local setup with using Minikube. And then we have seen how to change the cr.yaml. And instead of applying all the CRD, RBAC secrets separately, we have deployed that using that bundle.yaml in the same file, because that is what needed for our test environment. And how to change the parameters inside cr.yaml. And when you're changing cr.yaml, you have to change that out unsafe configuration as well, because we are operator thinks that something has been happening differently. So when you are changing configurations, you have to tell our operator that that is fine. I have made that change manually. So to instruct that, we have enabled that unsafe configuration, and then we have started our database within one Minikube. And after that, we have seen how to connect to our how to check our username password created, how to decode them, and how to see the plain password, and how to connect to our database by logging into pod directly, or by connecting through a URI. So we have seen these things. We have to see how to install our operator using Helm charts, that we can see as a separate video series. Also, we will see how to work with secrets like our usernames, and how to change. So it's not about you are going to deploy, change your username passwords at the beginning of deployment. After deployment, if you want to change the username password, how you can do that. That we will see. How to edit our white tiger cache size, and how to change our CPU cores or memory. These things we will see in our next video series.
Okay, yeah, so excited for that. So thank you so much, Vinod, for your time. And if you have some questions, people who are watching this video, so please leave us your comment below. Also, don't forget to visit our operators in GitHub. We have Percona operators for MongoDB, like Vinod said, for MySQL, and also for Postgres, and all of this is open source, so you can explore it and also leave us comments and feedback if you are interested in using it. Thank you so much, Vinod, and have an amazing day.
Yeah, have a nice day. Thank you. Bye.
See you in our next video. Bye. Bye bye.